Hello.
Uh-oh. Better not say something like shit. Oh, I did. All right, guys, so I added something. Let me show you this real quick, and then I'll see if you guys have any questions. So right here, I put the, what do you call it? The probability worksheet. Remember that we started working on yesterday? We have to finish it up. But on the other side, so if you click here, we did number 1 and 2, and then I spoke a little bit about 3. So we're going to finish up 3 today. And on the other side was a practice quiz, right? And this is, you do this on your own time. You can ask me questions about it. I have uploaded now the answer key. So if you click here, you get the answers. And look, I even did it not in my own handwriting, so you can even read it. That'll be different. Everybody with me? So you can, if you want to try that out, you don't have to. It's completely up to you. It's just extra study guide. And you have the answers there, so you can double check here what you got. So anybody have questions from homework or general questions? Before I forget too, while you guys are thinking, somebody helped me out earlier, and I have unlocked the last quiz. So if you go to make corrections, you can now go back in and see which quiz you took. So you can, if you didn't write down all the questions, does that make sense? So you can make corrections to the last quiz. I've unlocked the quiz, and I can go in and see what the questions were to help you make corrections if you need to make them. Okay. Everybody's cool. Everybody's good? Everybody good? Not very many have gotten into chapter 3 homework yet, so that's concerning and understandable at the same time. But you want to do that because what's happening, what was supposed to happen today that I'm being really nice about?
A quiz.
Yeah, so we were supposed to have a quiz today, and I pushed it off till Monday. It's going to be on just chapter 3. So you desperately need to get that homework tried out over the weekend so you are ready for Monday. All right, so let's do this. Here we go. Oh, yes, so just let me show you this too. I'm glad I got this. Somebody just sent me a question. If you'll notice, in the quizzes module, there's a place for quiz 2 corrections. So no matter how you turned in your quiz 2, some of you turned it in here, some of you emailed it to me, some of you made it into a paper airplane and threw it in my direction. You can still turn in the corrections all in one place, thank the gods, right? That will help me out immensely. Is that cool? I'm going to assume that's okay for the person that asked the question. I like it. Okay. Anything else? You're welcome. Okay. Okay. I'm an optimistic fool. And like I said, not many have tried chapter 3 out. So that explains why you don't have a lot of questions from it. But anyway, all right, we need to get in there. So let's do this. Let's finish that worksheet we were working on. Pull it back up here. Where were you? All right. So for some reason, I thought I saved it with all the work we had done, but unfortunately I didn't. So, oh crap. I'm going to undo this immediately. Okay, now I've got to shift you guys over here. Let me shift this thing over here. Let me share my screen. All right, let me get my technology. So we did all these yesterday, right? And we stopped right here at number 3. Okay, so let's look at number 3 together. I kind of got us started, but I want to kind of highlight something you have to be careful about. It's going to come up in the homework also. So most of the time we don't need to use formulas for probabilities, but when we do, we really want to make sure that we know exactly what numbers go where in our formula. So one big piece of that is knowing how to write in symbols what it is I'm using. So somebody give me an idea, what's the 7% relate as far as probability? That's the probability that what?
What was the question?
The Americans who think chocolate milk comes from brown cows.
This 7% represents the probability that some American that I pick will think that chocolate milk comes from brown cows. Somebody help me out. What symbol do you want to use for that situation? What do you want to put in here to represent this situation?
B.
Say it one more time.
B.
B, okay, B, I like it. So B for brown, right? I like it. So that would be 0.07. So what's the probability that somebody doesn't think it comes from brown cows? And let me show you, the book uses this prime symbol to mean not. I don't know if you guys have run up against that. That little prime means not B. I will more than likely use this. That to me means not. That means not B. So what's the probability that an American I pick does not think that chocolate milk comes from brown cows? What's that probability?
93.
0.93, I love it. Is everybody cool with that? That's pretty straightforward, right? So if I select 4 Americans, what's the probability that the first one thinks chocolate milk comes from brown cows? So that means the probability that the first one thinks that chocolate milk comes from brown cows, while the last 3 don't. Okay, let me stop for a minute. Do you guys get the idea here? That's just a quick way to summarize what that is asking. And there's a hidden and. There are several hidden ands. I want the first dude to believe that, and the second dude not, and so forth. So, of course, what's the operation going to be to calculate this? What does and mean?
Multiplication.
Or means something.
Multiply.
And means I like it. And means multiply. So I'm going to have 1 person, 2 people, 3 people, 4 people. So the first one, I want to have them believe that chocolate milk comes from brown cows. So what number I'm going to put right there?
0.07.
And then I want the last 3 to not believe that. So it's going to be 0.93, 0.93, 0.93. 8, 7, 2. I think it's going to come out to be about 0.5 something.
$5.63.
So it's 0.0563? No.
5.63.
No, it's not 5.63.
0.0563.
0563, okay, thank you. Which you can then make into 5.63%. That I agree with. Okay. Let me stop for a minute. Do you guys get the feel for that? So what's really interesting is I'm controlling each spot. So it says very specifically, I want the first dude to believe it. So that's a 7% chance that that person believes it. and the second dude not, that's 93, and not, and not. So if I had 8 people, you would just add in 3 more spots or 4 more spots. There you go, Jeff. And then put the appropriate probabilities in. You guys okay out there? Okay. All right. You're like, this is okay, Jeff. Just not terribly exciting. I know. It's fine. Now here's the kicker. All right, and I really want you to understand why this is harder than you think, and then there's a shortcut. So what does it mean for at least one of them to think this is true? What does that mean for at least one of them? What does that mean? What's one way that at least one of them could think it's true? All right, what does at least one mean?
1 or greater than.
Good. So 1 or 2 or 3 or 4, right? Because there's 4 people total, so that's the most. But I want you to really understand. If I think, so probability of at least 1, let me really blow your minds. It's the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4. Let me stop right there. Is that okay? Because at least 1 means 1 or 2 or 3 or 4, and that's why there's pluses, because what does or mean? Add. This is even more work than it looks like. Because how could you have one person think so? Well, it could be like this, or the second dude could think so, or the third dude could think so, or the fourth dude. And then for 2, it could be the first 2, or the last 2, or the middle 2, or the first one and the third one, or the second one and the, holy shit. Holy shit. Do you guys understand how much work that would be? Does everybody understand how that seems such like a little tiny question? At least 1. But there's a shit ton of ways to do that. So there's a quicker way to do this. So tell me this. This is going to seem completely irrelevant, and I don't apparently care. If the probability it's going to rain today is 5%, what's the probability that it won't rain?
90.
95%. So how do opposite probabilities work? One is always 1 minus the other one. And I know I'm saying that like it's something profound, but I'm hoping most of you guys go, well, yes, Jeff. So if the opposite, now look how slowly I'm talking. Do you guys realize how fast I normally talk? So if the opposite probability is easier to calculate, I'm going to do that and then do 1 minus what I get, because that'll make it the answer. So if somebody says, what's the probability it's going to rain today? And I say, well, there's a 95% chance it won't rain. And he's like, what the shit? The answer right, and they go 1 minus that 5% chance that it will rain. So I really want you to get this. So first we answer the opposite question, and then we do 1 minus that, and we answer the freaking question. So now the question is, what is the opposite of at least 1? If I knew that, I just have to do 1 minus the probability of the opposite. What is the opposite of at least 1? If I said at least
less than 1? Less than 1?
Yeah, sure. Now, can you be more specific?
95%.
No. Sorry. I'm not talking about the rain thing anymore. I'm talking about 3B now, right? I agree with less than 1. What does that mean in the context of I have 4 people?
So it would be 3 then.
Say again?
Would it be 3?
So if I said, I think at least one of you guys wants to become a stats major, right? How could you show me I'm wrong? Which means you would prove the opposite. How would you show, if I said at least one of you guys wants to become a stats major, how would you show me that I'm wrong? Come on. If I said at least one of you guys loves this shit, how would you show me I'm wrong? Oh, I got a chat from a shy person. Love it. Oh, not so shy, I guess. Put the population. I have no idea what that means. I'm sorry. Put the population. I don't know what that means.
Would you put 4 for all Americans?
All right, no, stop. Just look at me. We're not looking at this. In fact, here. We're not looking at that. If I said, I think that at least one person in this class wants to go on and become a statistics major, how would you show me that I'm wrong? What would you have to do to show me that I'm wrong?
Stating your major
Opposite.
stats.
Say again, sorry.
Saying that your major is not stats.
But listen to me very carefully. I'm not talking about one person. I'm saying I think at least one person in this class would like to become. Yeah, it's so funny how you guys are bouncing around the right answer. Just show me that nobody. Show me that none of you want to, right? So what is the opposite of at least one? None. Right? What's the opposite of at least one person wants to go with me to the movies? Nobody wants to go, right? Because nobody wants to die. So I wouldn't go to the movies, kids. Indoor ventilation shit, don't do this. Maybe, are you guys doing all right out there? What's happening? This isn't anything major. This isn't anything profound. It is something different than you're used to. But can anybody tell me, does it not make any sense at all? The opposite of at least one is none. In fact, help me out. I'm going to beat this horse until it's beyond dead. So just go with me. I have 4 people. So how many could believe this? None of them, 1 of them, 2 of them, 3 of them, 4 of them. Can you circle, well, here I am doing it for you. Can you circle all the ones that represent at least 1? Where's all the ones that represent at least 1? Yes, you can. I mean, you can't, but if you wrote those on your paper, couldn't you circle them? Where's all the ones that represent at least 1? These, right?
You're not
I
sure.
can't see your screen.
Shit, I'm sorry. All you got to do is tell me this, guys. I'm sorry. You got to remember, I am not an online teacher normally. Can you guys see it now?
Yes.
Yes.
Okay, let me start over. I didn't have to erase all that shit. Okay, so if you write down, if I have 4 Americans, I could have none of them, 1 of them, 2 of them, 3 of them, 4 of them that believe chocolate milk comes from brown cows, right? Those are the possible things. Which of those relates to at least 1?
1 through 4.
1 through 4.
Yeah.
So what's the opposite of at least 1?
2.
0.
None. That's what it leaves out. What's the opposite of something need? Everything that it leaves out. So if I say the probability somebody is left-handed, what's the opposite of that? That's everything that it's left out, that isn't left-handed, right? You guys with me on this? No? Okay. So another way to get to where we're going. Can somebody tell me this? Get out of there. Get in there. Okay, now watch. Let me push what I just did a little bit further. If I add up the probability of 0 plus the probability of 1 all the way up to 4, what does that have to equal? When I add up all the probabilities, I had better get what? 1.
1.
What are these? These are the probability of at least 1, right? So if I subtract the probability of none, won't I get the probability of at least 1?
Yes.
1 minus none
Yes.
is the probability of at least 1. So that's a whole other way to realize that that's what I want to figure out. And what kicks ass about none is there's only one way to have none of them. So how would I do P of 0? Let's focus on that. How would I have nobody think this weird thought? Let me change my color around here. Let's do red. right? So I got 4 people. I want none of them to believe this crazy thing. So all of them would get what probability? They don't believe this.
93.
93, yeah. I don't want any of them to be crazy. So now listen, if I figure out the answer to what I just wrote down, that is the opposite of what the question was. That is the exact opposite. So then if we do 1 minus this, we answer the question. And what really sucks is I don't think you guys understand still how much there is a lot of work just to do this. And then you still have to do this. And there's a shit ton of work there. And then you still have to do this. And then you still have to do this. I would much rather do 1 minus this one thing and be done with it. So how do you do that in your calculator? Well, how can you write this better? 1 minus 0.93 to the
4th power.
4th power. So whatever the hell that is.
0.2519.
I like it. So Nick, it's almost like you're on a game show. You're just right on there. Yes.
That's what I was thinking.
And I am very sorry, but I have no real gifts for you. I was trying to be a 9 back there. Don't give him any grief. Okay. Okay. So that works. That always works. If the probability of the opposite situation is easier to calculate, of course I'm going to do that shit. And then do 1 minus that. Because that's how opposite probabilities relate. At least 1 is an extreme example of that, because the opposite of at least 1 will always take less work. Because the opposite is just none.
So
no, why is it only up to 4 for this problem? Why is it only 4 that I'm worried about for this problem?
They only selected 4
American.
Yeah, so if I had selected 11 Americans, then how would I have done this? 1 minus 0.93 to the 11th, right? So why is that a 4th power? Because I was selecting 4 people. Let's see, people are chatting at me. Oh, I see. Okay, see, beautiful. Now let's just stay here for a second. I got a really cool question on the chat. By the way, I always think about I'm going to do Big Lebowski shit, but it just helps me out with my technology. But I'm not going to go bowling later. Sorry. Where am I at? So somebody just asked, what about the at least 2? So the probability of at least 2 would be the probability of 2 plus the probability of 3 plus the probability of 4, right? So what's the opposite of this? What's left out of that? 0
And 1.
and 1. So you kind of have to go on a case-by-case basis. So is this really less work than this? You'll have to see. Yeah. So what happens most often is the at least 1 thing comes up. That happens a lot. But this is what I meant. This is a beautiful example because you have to kind of see which one would take more work. This one looks like it would take more work. And it would. So I'd rather do this one. This is still a decent amount of work, but it's a little bit less work than this one. So the larger thing to realize is, like I said, anytime the opposite probability is easier to do, you do that. And then you do 1 minus that to actually answer the question. Okay. This idea is going to come up a few different times in a few different ways. So we're going to get to play with it a little bit more. How's that? Is everybody okay? So that was a really good question. I like that.
Can we work out that problem then if the question was phrased as at least 2?
Yeah, sure. Let's see. I don't have that much room on here, but oh, let's see what I can do. Get out of there. Get out of there. Go away. All right, Jeff, you don't have to. Yes, I do. Okay. Let me come up here. Let me see. Do I have more room somewhere? No, I don't. So I'm going to just do it here. So we already got the probability of none, didn't we? We already got that. That's right here. So I got to figure out what the probability of 1 is. And I want everybody to realize we're going a little further than we needed to, but this is a decent question. So do you see how, I really want you guys to see this. I know there's a lot of shit up here, but do you see how this very first question, part A, this is not the probability of 1 because it doesn't have enough possibility. This is just one way. This is if the first one believed it, right? I really want you guys with me. 3A is too specific. How many ways can you have one person believe something out of 4? It could be the first guy. Sorry?
4 ways.
4 ways. It could be the first guy or the second guy or the third guy or the fourth guy. So you would have to do the probability of B and then not B, not B, not B. And then probably of B, of not B, and then B, and then not B, and then not B. But do you notice how, I really want you guys to get this. Do you notice how they're all going to be this over here? Right? If I just move the 0.07 there and move that 0.93 there, isn't it the same number? So what I can do for the probability of 1, it's going to be 4 times 0.0563. Because I'm going to get 4 of these. I'm going to get 4 0.07s and 0.93 to the third. All right. And again, we're going a little further than we really have to at the moment. So we already know what the probability, and then I add the probability of 0, which is 0.93 to the fourth, whatever the hell that is. So that'll be the probability of 0 plus the probability of 1, and then I take that 1 minus. So I got to figure out what this is. So this is answering the opposite question, and then do 1 minus what I get. So when I do this, I get 0.9733 if I round it. Dadgummit, pen. So then if I do 1 minus that, I'll get the probability that at least 2 people. Where do you go? 0.267. Woo! All right. So again, the last bit we just did is beyond what I would necessarily ask you to do for this, but it was a good question. So what the hell not? Oh, here comes somebody with a chat. Yeah, I thought I totally could. I'm gonna erase this shit though because I gotta answer part C still. It's gonna be on the video that I post to YouTube. I thought I had saved the page with all the work from yesterday, but apparently I didn't. It didn't save. So I mean, I could save this, sure, and post it, but it will also be on the video that I'm gonna post to YouTube. So I could do both, sure. But I'm gonna erase this last bit we did for 2 reasons. I need space for part C, and this isn't really part of this work. You're welcome. All right. You thought nothing could be more exciting. But then I came along and let you watch me try to erase shit on the screen. All right, Jeff, just let it go. Let them stay there. Okay, they can stay. Okay. So coming back to stuff you will definitely need to know how to do. So what did this represent again? What does that represent? What is P of B? Sorry, go ahead.
The Americans that think chocolate milk comes from brown cows.
I love it. Now look at what I throw in here. If we also know that 4% of Americans think that chocolate milk comes from brown cows and that Brussels sprouts are the best vegetable. So what letter do you want to represent Brussels sprouts? We can't use B. This is already used there.
S.
So I mean, S, that's crazy. So how would I write the symbol that represents 4%? 4% think this and Brussels sprouts are good. What would that symbol look like? Or what would I write? I mean, it basically writes itself.
B.
What's the, sorry, go ahead.
Would you put B and S together?
Yeah, but like this, right?
Mhm.
The probability of B, which is this, and S, which is Brussels sprouts. And what are they? So this is what they tell me. And so what's the value of this? What is the value of that? What is it? What's the numerical value of that? It just tells you. So if you're trying to do work, stop. Say again?
4%.
4%. It just tells you. This is going to happen in the homework. You are going to have a paragraph where it tells you the probability of this and this is 0.72. And it's going to be all about, can you write those in symbols? So that when they ask you a question like this, what does the question look like? Using the symbols that we used over here. What does the question look like? Let me erase this poor little, there we go. Look at the question. How do you write the probability of who to what? What goes in here?
B given.
No.
S given B.
S given B. I love it. Sprouts given brown cows give milk. Give chocolate. Stay with me. Stay with me. I feel the energy of people having left the conversation. Stay with me. What's the formula for this? Can you look it up? What the formula is, or do you know it? What the formula is for the given? So what's A given B? What's the formula for that?
P A and B over P of B.
And on the quiz, I'll have the formulas on there. So I don't make you memorize formulas. I do make you recognize them. I'm not going to identify what they do and what they are. I'm just going to give them to you. So how do I write P of S given B?
P of S and B over PB.
Yes, P of S and B over P of B. I like it. So A and B are just dummy variables, sort of like X and Y. You can replace them with other letters. So if you have a formula for P of A given B, you can just replace A and B with whatever the hell other letters you happen to be working with. Let me see if I can't write that a little bit better. There we go. So what do you know here? Do we know the probability of S and B?
Or 4.
Yeah, they're probably, yeah, it's right there. Who cares that they're out of order? If I said Jim and John and they're like, no, you mean John and Jim. I'm like, shut up, come with me. So who gives a shit what order they are around it with the word and? So that's 0.04. Do we know what the probability of B is?
07. 0.07.
0.07. So whoever wrote that in chat, Frida, perfect. So now I just got to do 4 divided by 7, which I think is 0.5714.
0.5714.
Kick ass. I do have my divided by 7. Not really memorized, but I have a way to do it. Anyway, you guys like, whatever, dude. You're the math geek. Be quiet. All right, so real quick, what have we learned from part C that's most important? I will never give you this cow and Brussels sprout problem. I will give you a problem that's just like it. So what's important here? Write the symbols for what they tell me. Write the symbol for what they ask me. So then I can write its formula down, and then I can go, what do I know? What do I know that I can throw in? What do I don't know that I need to know that I can figure out? So once you got the formula written down, it was easy as shit because they just basically tell me everything I need to know. Okay. Maybe. All right. So any questions from that? So just to remind you guys, attached to this is up on Canvas. If you didn't know, this is up on Canvas. And down here is a whole practice quiz. And I have also posted all the answers in the same place up on Canvas. It's in the Unit 3 module, believe it or not, because this is Chapter 3. It's crazy. Okay.
We have time to figure out if S and B are mutually exclusive. Could we work that out?
Oh, we already know the answer to that. I mean, we haven't. Well, I mean, what does it take to make two things mutually exclusive? What has to be true?
0.
What has to be 0?
Right.
What has to be
S
0?
and B, the probability.
Yeah, and what is the probability of S and B?
0.04.
So are they mutually exclusive?
Yeah. No.
In order to be mutually exclusive, the and has to be 0. The and here is not 0. They are not mutually exclusive. Let me see. So no, I'm getting a question in chat. Is there a certain pattern we need to follow to solve these problems? No. Here's the thing. Let me say it again. In fact, let's do this. I'm going to help you out a little bit with a homework problem. So let me stop sharing this. We're going to look in the book at a homework problem, a little preview if you haven't done this yet. Just to show you what I'm talking about when I say that the homework is going to have this kind of thing in it. See if I can find it relatively quickly. Yeah, here we go. Here we go, perfect. Okay, let me share this. All right. So I'm pretty sure I assigned this one. Pretty sure I did. Let me see if I did. Oops.
Yeah, you did. It's on there.
Okay, thank you. So here's the thing. I'm not going to do this whole problem because this is your homework and I'm not in the practice of doing other people's work for you. But let's do a little bit. As you read through this, don't just read through it and then come down here and start trying to work these problems out because that's crazy. You got to know what the hell they're giving me. So the 61%, look at the symbols they use. C means California registered voters who support same-sex marriage. B means registered voters who say the Supreme Court ruling is important to them. And A means registered voters who are this old. Okay, so they already give you the symbols. Sort of like we had B for brown cow and S for Brussels sprouts, right? So 61%, and you can read what it is. What symbols would I use to represent 61%? The probability of what exactly?
C.
Yeah. Bam, because that's exactly what C is defined as, right? You guys with me? So I know P of C equals 0.61. And do you guys realize that that is the first question, right? So now let's go to the next percentage I see. 78%. Now this one's going to be interesting. Let me see if you guys can realize how to write this.
Is it-
Well, this one is not the interesting one, I guess. Where's the interesting one? I guess it's coming up.
The 6 to 10 California registered voters.
Yeah. Yeah, that one's a little bit interesting because you can miss it really easily. So now watch this. C means registered voters who support the same-sex marriage. Among 18 to 39-year-olds, the approval rating for this was 78%. What does the word among mean? What probability idea does that relate to? If I only look at this age group, the approval rating becomes this. So supporting same-sex marriage, that's the probability of C, but given that they were what?
18 to 39.
18 to 39.
So the word among is kind of a standard for given. Given that they're 18 to 39, the approval rating would be 78%. Somebody's chatting at me. I love how you. Okay, there we go. Exactly. So let's see. So that's going to be where'd it go? 70. And that, of course, is this question. 6 in 10 California registered voters said that the upcoming ruling is important to them. Well, that's just directly what B says, right? So what's the probability of B? Right? The upcoming Supreme Court's ruling is important to them. That's exactly what event B is. So what's the probability of B? Yeah.
0.6.
0.6. Yeah, no evilness there. It's just 6 in 10 is 0.6. Yeah, 60%, exactly. I like it. So that, of course, is there. So guess what the last number is going to be? I bet you it's going to be this, and let's see if it is. So B given C. So given that they're registered voters, out of the registered voters, 75% say the ruling is important to them. So that is B given C. All right, so probably a B given C is 0.75. All right, so you are welcome. I have done 4 parts of the homework for you. There's another problem that's sort of like this that has a little bit less going on. I can't remember if I assigned that one, but hopefully I did. And see now, you know, when they ask you to find this down here for part G, you would write down what the formula is for it and then see what you got. Do you have everything you need to calculate that, right? So you'd write down the formula for C and B, you'd write it down, then you see, well, do I have everything I need? Oh, Javier, are you? Oh no, you're just playing with the pencil. Thought you had your hand up or something. Okay. All right, so that's a little bit of a homework freebie. This is a problem that if I don't hear questions about it, I get concerned because it is a little strange. I get people that always ask me, I don't know how to calculate these. And then I tell them, you don't have to, because they just tell you what those are. That's what all these things are. Okay. All right, so moving on. I don't see any reactions, any other follow-up questions, so I'm gonna keep going.
What is the formula for probability of A and B? Because I don't think I wrote it down.
Uh-oh. So, oh shit, I just moved everything. Let me see. So remember we got the probability of A or B, right? That'd be P of A plus P of B minus P of A and B. The probability of A given B is that. And then the probability of A, where'd it go? And B that's the one we did last time.
Thank you.
Welcome. Now just to show you, let me show you. Well, all right, let me stop sharing this. I want to go up on the board. I don't like this. Somebody got what they want from this chicken scratch up here? This will help you with number 80, obviously, a lot, because now you've got A through D answered. I'm going to stop sharing. It's going to go away. Bye. Okay. Let me take off my bowling glove. So if you realize that, help me out. What's the probability of A given B? That was,
We can't see. Can you move it up?
oh yeah, sure, sorry. Sure. Okay. So the probability of A given B is this. And if I multiply this up, I get this formula for probability of A and B. You'll notice that is a little bit different than the one that I wrote down. I really want you guys to stay with me. You gotta stay with it. Feel it. We know this shit is true. We created this formula. We made you. And then we can do a little algebra to solve for this. Well, tell me, what's probably B given A? What's that one? Let's see which marker's gonna work. Ooh. What's probably B given A?
And B over B.
Be careful, what's gonna be on the bottom?
Probability of A?
Yes, what's always on the bottom is what's given. So if I multiply this up, I can solve for A and B. All right, I multiply this up and I get. So what is very interesting is these two are true at the exact same time. You could use whichever one. They're both true. So if you write it this way and you're like, oh shit, I don't know what that is, but I do know what that is. Oh, I should use this way. Maybe. Yeah, so it all depends on, so this is kind of interesting that there's two options as to how to write this. And you use the option that matches what you know. That's all. Okay. Maybe. All right. So anything else from chapter 3? I want to really push my luck here and do one more problem that's kind of related to that at least one thing we did earlier. So let me do that. I'm going to erase this. you remember that whole thing I was talking about, the space shuttle blowing up and all that kind of stuff? And I also talked about using multiple alarm clocks, right? So let's say that the probability that this alarm clock, this kind of alarm clock you have, let's say that the probability it doesn't work. My house is tilted. All right. Probability it doesn't work, probability it fails is 0.02. So it's probably that it works.
Point 1 minus 0.02.
Yes, sure, yes.
$98.98.
Right, $1 minus 2 cents, 98 cents. So if I set 3 of these alarm clocks, this type of alarm clock, what's the probability that they all fail?
That would be 0.02 to the third power.
Yes, exactly, right? Because again, how many? I got 3. So I'm going to have 1 and 2 and 3. I want the first one to fail, so he gets 0.02. And this one fails, and this one fails. So like you said, 0.02 to the third power. I love it. And then what's that? Okay, what's happening? Is everybody doing this? It's not 0.08. Sure as all hell ain't.
I got
Nope.
8 to the -6 power.
8 times 10 to the -6, yeah.
Yes.
Yeah. Because of course, when you multiply decimals, the decimal place keeps going back by the amount. So see how there's 2 here? There's 2 decimal places. Real quick. 2 decimal places. So if I do it 3 times, that's 2, 2, 2. That's 6 total. 1, 2, 3, 4, 5, 6. Bam. That's why you got times 10 to the -6. If you don't like anything I just did, you got a calculator. Use that damn thing. I like it. Okay. So what is the probability that at least one works? So this would be the probability that you actually wake up. If you need an alarm clock to wake up. This requires remarkably little work.
It would be 0.
Say again?
0?
It would be 0?
No, 1 second. Hold on.
Wait, would it be 0.98 times 0.02 times 0.02?
No, because that would be the probability that the first clock works while the second 2 don't. That is not what I'm asking. So what is the opposite of at least one works?
None of them work.
None of them work. And didn't we already figure that one out? Didn't we just do the probability that none of them work?
Right. So
In other words-
1 minus the probability of them all failing.
Yeah, yes. Yes. I really want you guys to see that the suggestion that was made, while I understand why you make it, do you see why it's wrong? Because not only could it be the first one that, so at least one works. It could be the first one that works, or the second one, or the third one. You have to calculate those, add them up. Or it could be the first two, or the last two, or the first one and the last one. Or it could be all three. So you have to do all those calculations, add them all up. Or you could do 1 minus the opposite, which is quick. So this is too specific. This is if the question was, what's the probability that the first one works and the other ones don't? That would answer that question. That's not what this question is. This is definitely different. At least one means it could have been any of them, or any two of them, or all three of them. That's a lot of things to have to calculate. Screw that shit. I'm going to do the quicker way. Now, has anyone got a way to do this real quick? Do you guys know how to subtract? This is so cool. If you do 1 minus a decimal, it's going to happen to us a lot. You can just make all, how do you make this 9? It needs, how do you make this 9? Give it 9. And you keep going. How do you make that 9? 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 And the last one, how do you make it 10? That is a cool little trick. And I know you got calculators, and I don't care. I'm still going to show you how to show the calculator who's freaking boss. Who invented who calculator? Humans did, man. Okay. So real quick, just to talk a little bit more about what I just did. What would 1 minus 0.2547 be? 7 makes that 9, 4 makes that 9, 5 makes that 9, 3 makes that 10, done. So that's a cool little shortcut. And we're going to do this kind of thing a lot. So I like to show that shortcut. Okay.
So everything except for the last number is 9?
Yeah, everything, yeah. And I really want you to, if you make everything 9 except for the last one, right? When you add these together, you'll get 0, carry the 1, 0, carry the 1, 0, carry the 1, 0, carry the 1, 1. That's why if you write down the number that would make this 9, and then make the last one 10, you're guaranteed that this plus this is 1, which is why that's the answer. All right, thank you. Somebody's chatting to me, make me feel better. I like that somebody said cool trick. I like it. Thank you so much. I try. I really do. And then some of you guys are like, dude, I got this thing. Shut up. Stupid thing. We should know how to do some stuff. We are the humans on this earth, right? We don't let the calculators take over and it'd be a really strange Terminator situation. We don't need Skynet. We just need TI. All right. All right, that's enough of this. So if I were you, I would do all the chapter 3 homework, and then I would glance at the practice quiz just to see what kind of questions I like to throw at people. They're basically the same kind of questions we've already covered. But you know, it's out there if you want to take a look at it. We're going to get a little bit into chapter 4 now, unless there's any specific questions from chapter 3. Maybe you guys want to take a break? Anybody? Yes. All right. So let's take a 10-minute break. What time is it right now? It's so come back at 2:40. I'll give you 12 minutes. Come back at 2:40. Let me cut off the recording. Everybody come back. Wherever you are. Hello. All right, guys. So we are going to get into chapter 4 a little bit. And what's going to happen over the next few chapters, if they give me data in a different format, and in fact, let me ask you this. What are the 2 most important things to calculate if I'm given data, no matter how I'm given the data? What are the 2 most important things I can calculate? Say it louder. What? I thought I heard part of the right answer, but I wasn't sure. How can I summarize a set of data by calculating two things? Okay, one of them is the mean. I love it. You want to tell somebody where the middle is, right? And what else will help me?
Range?
No, the range isn't good enough. The median is just an alternate for the mean.
Most.
Did I? No. I love you guys. We already got the center. So the mean is the best measure of center. And if it isn't, we might use the median instead. But the mean kind of wins. What else besides telling somebody where the middle of the data is? What other idea is there that would give me a summary quickly?
The high and the low.
So that's range is not good enough. We develop something
Standard
better
deviation.
than standard deviation. There it is. So every time we are given data in a different way, not just a list of data, we want to develop a way to find the mean and the standard deviation quickly. So today we're going to see our first different way to be given data. So what I want to do first is show you the connection between what we already know how to do and what we're about to do. I always try to make a bridge there for you a little bit. So let me show you this. What I'm about to do is the math behind what we're going to do as a shortcut. I want to show you why the shortcut stuff works. So first off, I'm going to give you a list of data, but then I'm going to show you how they're going to give it to us in a different way. So if I gave you this data, what do you got, Jeff? How many is this? 1, 4, 7, 8, 9, 10. I like it. All right. So here's a list of data. So this is the way we would get it in chapter 2. Whoop-de-doo. Tell me how you would calculate the mean. What would you do?
Sum of all the data.
Yeah. And I could kind of do it smart. I could say there's 4 ones, right? And there's 3 2s, and there's 1 3, and there's 2 4s. Is that cool just to make this quicker? Of course it is. And then divide it by 10. Now, so here's the old way. If I just do this, what do I get? 4 plus 6 is 10, plus 3 is 13, plus that's 21. I think it's 2.1. Is that right? Sounds like it should be about that. I think so, yeah. Let me stop for a minute.
Yeah, it is 2.1.
Like it. So here, now I love it. I love it. I have to do this every time I do something like this. I'm about to do something you will never do. We will never do what I'm about to do. What I'm about to do explains why the shortcut we're going to use works. Remember that. So I'm about to do some weird shit you would never do. And then I'm going to connect it to something and make it, apparent why we do it. Here we go. So if I, instead of going that way, if I keep going, couldn't I write this as 4/10 times 1? Right? I could if I wanted to, couldn't I? And then this is, let me make it even worse so you guys really start to worry about my mental condition. But notice, what does this 0.4 mean about the ones? What did the 0.4 mean? What does that mean about the ones? You can do it. What percentage of the data is 1?
40%.
40%. That's 40% are 1s, 30% are 2s. So it looks like to calculate the average, I can do the weight times the value. The weight times the value, and so forth. So this is 0.4 plus 0.6 plus 0.3 plus 0.8. If you add all that shit up, you get 2.1 still. Of course, the math doesn't care if I add and then divide by 10, or if I divide by 10 and then add. It doesn't care. All right, so now, again, all of this, you will never, ever, 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 ever do like this. So let me show you what this would look like. You're gonna get rid of this. I don't know if anybody's still copying down, which you really don't need, but this shows you why this works. See if I hear anybody yell. All right, let's go. So now watch. Here's how they're going to get. They're not going to give me the data like this. They're going to give it to me like this. So this does mean 40% are ones, 30% are twos, and so forth. So how do I calculate the mean? I just multiply these. So 0.4 times 1, 0.3 times 2, 0.1 times 3, 0.2 times 4. What would I write here to represent in symbols what these are? What would I write right there?
X times P of X.
Yeah, X times P of X. Is that what the shit they are? I multiply the X's and the P of X's. So if I add these, that's the mean. But what would the symbol be for what I'm doing? What's the symbol for add?
Sigma.
The summation.
Yeah, sigma. It's the big ass E dude, right? Sigma. And I would accept big ass E dude. That'd be fine if you told me that. I would know what you meant. Big ass E dude, X P of X. So if I add these, I get the mean. And of course I still get 2.1. It's the same data. So just real quick, we'll do another problem here in a minute, but I want to show you, just in case anybody is out there saying, why the hell would I do this and then put it here and do all this weird shit, Jeff? That's not what I'm saying. They wouldn't give you this. They would give you just this. What if they give you, what if they give you this here? Oh boy, Jeff, really? And then whatever the shit that has to be. Because what do I have to have these happen? What has to happen with these? What do these all have to do?
Multiply by the number on the left.
What do these by themselves have to do? I can't just put anything I want there, right? What are these?
They all have to equal 1.
They all have to add to 1. So of course I picked these disgusting. Let's see, 6, 7, 7, 5, 7, 6, 7, 7, 3. I think this is 2, 2, 7. I'm not sure. It does make sense. So I just in case you guys are like, well, I would just write 4 1s and 3 2s and do it the old way and screw you, Jeff. I would say, what would you do with this shit? There's 137 5s and 429 6s. You want to write them like that? No, you don't. I would much rather just multiply and then add. And that gets me the mean. So that's the point. I want a quick way to calculate the mean. And the next thing we got to look at is how do we do the standard deviation? All right. I love you guys. But what I desperately want you to remember is that the math we do when we multiply and add, it does match up with the math that we used to do. It's not like it's new math. That's why it's still the mean. And if you look at this, what was the formula for the mean before? It was this, right? That's the mean, right? So what looks to be missing when I write this? What looks like it's missing? What's obviously kind of missing there? You can do
The
it. I mean,
end.
what's the end? But what's on the bottom of any probability?
Total of all the numbers.
Total number. What letter do we use for that? We use freaking n. So on the bottom of P is n. These are the same stupid formula. It just looks different because our data is given to us in a different way. That's all. Okay, maybe. The math is the same. It just looks different because of how they gave it to us. Maybe, maybe, maybe. Okay, now watch. So what was the formula for the standard deviation? What was the formula? In fact, let me just say the variance. What was the formula for the variance?
Sum of x minus the mean squared. And then depending if it's a population or sample, it will be n divided by n.
Good. And this one I've got the good old population sitting there. And some of you guys might realize why I'm using population symbols, because again, what is on the bottom of P is n, not n minus 1. So it's got to be a population symbol I'm going to use. All right, let me stop for it for a minute. So normally, back in the day, the first thing I would do to figure out the mean is I would sum up my x's. But if it's given to me like this, before I add them up, what do? I multiply them by this, and then I add them up. So back in the day, I used to make a bunch of these and then add them up, right? But now, in exactly the same way, I can't just add each one of these up because 40% of the numbers would be related to this one. So I've got to adjust this formula. I have to add up these after they've been multiplied by the probability the same way. And again, you see how it's the same formula because what's in the bottom of P? Freaking n. It's the same formula because that P's got an N in it. It's like ragu. That might be an old reference. Sorry. It's in there. No? No good? Okay. All right. Now, oh, I can sense how much you're gonna love this next part. Okay. All right. Oh, you all hate me, and this is too bad. Now, what I'm gonna do to give myself a little more room, because I wanna leave this here. Let me flip this dude and see what's on the back of this. Oh, there's some old shit on here. All right. We're gonna come back to that problem in a minute, so don't just think that's gone. Oh man, I'm gonna watch this anyway. Okay, now look at this bad boy. This really sucks because you know I've got a table and I've got this and I'm gonna have this, and then this says, okay, screw all that. Figure out what the mean is, and then subtract it from each x, and then square that shit, and then, oh my God. There's got to be a quicker way to do this. All right. So if you saw this in algebra, what would your instinct be to do? If you just saw this, and the problem said simplify, what would you do? Anybody? If you saw this, or maybe if I wrote it like this, is this better? What would you do here?
Factor.
It is factor. So I'd write it twice. And then what would I do with it?
FOIL?
Yes. So if I write this sucker twice, go ahead and FOIL it out. I've been doing too much work. You guys do something. Multiply that out. All right, let's see. Let me catch up to you guys. What do you guys get? I get
X squared minus 2x mu plus mu squared.
So hopefully everybody got that. Not a major thing. You get the little mu dude, but algebra doesn't give a shit what's in there. It doesn't care if it's Greek letters or what. So let me plug that back in here. So this will be the sum of this times P of X. Oh, I can just sense that today is your favorite day so far in this class. Just stay with me. This is not work you're going to ever have to do on your own. We are developing a better formula than this. So this is just you kind of suffering through the making of the sausage here, and then we're going to be able to use the formula we get directly. So just stay with me. What would I do next with this?
Once you distribute it?
Yeah, so wouldn't the first thing I get be this? Minus other shit? Right? And just to cut to the chase, because this class is not a summation algebra class. So I'm just going to tell you, believe it or not, all the other shit you get simplifies to be this. Sometimes I make that a bonus question somewhere. Prove to me that this becomes this. But in general, you don't have to. You can take my word for it, or if you don't trust me, you can try to do it yourself. All right, so let me come back to the other side. So so this is our variance formula. This is our formula for the variance, and I want to prove to you that this is better than this. This is so much better than this. So I'm going to go to the other side without knocking myself out. That always helps. Okay. So if my formula is now, I wish I would have left myself some more room. It's too bad, Jeff. I'm going to put it up here in blood red. My formula is now sum of x squared p of x minus the mean squared. Right? I don't know if you guys can see that. So this part right there is the next important thing. Do you guys remember, I told you how to be ready. I told you that this symbol was going to be in a lot of our formulas. If I cover it, I see what column I need. Do I have a column of these yet? No. I had a column of xp of x's, and the mean formula is the sum xp of x. Okay, who cares? I just add those up and done. Yay. But what do I need for this formula? I need a column of x squared p of x. And by the way, I do have a handout where one side is a completely worked out problem and the other side is going to be one for you guys to work on. It's up on Canvas. So you have a kind of a reference, right? So all I have to do, what's beautiful is I have to do all this shit already just to get the mean. And if I write this formula this way, I just need one more column. Now, does anybody have a way to get x squared p of x? I mean, there's a very direct way you can do it. I mean, how did I get x times p of x? I did the x row times the p of x row. So how do I get x squared times p of x?
The x row squared times the p of x row.
So one way to do it is to square these and then multiply by these, right? That'll totally work. But what I want to show you is something that hopefully you'll agree with is actually easier to do. Watch. What would x times xp of x? What's x times xp of x?
X squared p of x.
So if I do this times this times this, I can get it directly without having to square a damn thing. I've already got the parts I need. So I can do 1 times 0.4, 2 times 0.6, and 4 times 1. So if I add these up, what symbol would I use to tell me what it is I just did? So I'm going to add these. So the sum of x per p of x equals what the sum of these are. So whatever those add up to be. Okay.
Like 5.7.
Cool. So then I can come over here. Give myself a little more room here. So I can come over here. That goes in right there. So what's the variance going to be? It's going to be equal to, well, what is the sum of x squared p of x? It's 5.7. What's the mean? 2.1. And whatever the hell that is, that's my variance. Let me stop for a minute. You guys have got to get used to entire things getting replaced with a number. Because 5.7 is the sum of that. So that whole thing gets replaced with 5.7. You're just not used to that. I understand. You're used to replacing a single letter with a value. And then whatever the hell that is.
$3.6.
What is it? Oh, 4 point. I was trying to do this in my head. 3.6?
Yeah, 3.6.
Interesting. No. You just did. No. There we go. This is squared here, right? Yeah.
Right, squared.
You squared.
Yep.
So let me rewrite this a little bit. My poor board. I needed to get the next size up, I think, but oh well, too bad. So let me rewrite the formula here. I'm kind of glad you did that because the most common mistake people make is to forget the square on that poor dude. So the sum of this is 5.7, and then the mean is 2.1. And then, I'm sorry, who said what they got? What did you get?
0.29.
0.29?
1.29.
1.29. That's not 1.29 is stops.
Yes.
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 Okay. And then what would the standard deviation be? Because of course that's the variance. And what do I do to get the standard deviation?
1.1.
Take the square root.
What is it? 1.136?
1.136. Yes.
All right. All right. So let me show you this. Any questions on that? I mean, this is the first time we're doing this, so you gotta do a few before you really get the idea. So let me show you the handout that I put together. Get in here and block all this work. See where I can be. I can be here. So if you go to Canvas, go to Modules, go down. Wait a minute, where are you? Wait, which class am I in? Oh, wrong class. Sorry. That was scary. Let's see. Go to Modules. And this is Chapter 4, so Unit 4. Right there, Probability Distribution. So I have a worked out example on one side. And look what I've done for you. I don't know if anybody was considering this, but you can do these in the calculator the same way that we've done other things. So what I want to do, hopefully, are any of you able to access Canvas right now? If you can, go ahead and pull this sucker up. What time we got? Okay, not too much time, but I at least want to show you this. So, and I should have asked this earlier. You don't have to do this right now, but I'm going to keep asking at the beginning of class if more people could turn their video camera on. That's always good for my mental state. But you don't have to right now. It's okay. We're almost done with class anyway. So what I want to do is I want to show you how to get this to show up in your calculator and remind you how to get these sums. Because when you get a longer list, it's always nice to just be able to have the calculator just do it all at once for you. So let me show you. I'm going to stop sharing. This is some examples of the kind of questions I like to ask. All right, let me stop sharing. Let me bring my calculator up. Where are you, calculator? There you are. No, not you. Go away, tips. I don't need you. All right. There we go. Okay. Come back over here. I like it. Let me share this. All right. So if I go to Stat, Edit, I'm going to clear this list. Go up to L1, clear it. So you can clear each list if you got stuff in all the lists. Oops, shit. What did I just do? There we go. And now what I'm going to do is I'm just going to put in, so let's see, 0. So in the first, oh shit, what did I just do? Okay, 0. That doesn't work, really? All right, 0. I can't input it on the keyboard. 1, 2, 3, 4. So I'm just going to put this stuff in off of this worksheet. And then over here, I got 0.02, 0.21, 0.34. I can't believe that I can't input it. Really true. There we go, I can. Yay. All right. Let me look at you guys. Where are you guys? There you are. All right, so if you're trying to play along, I'm gonna let you catch up. So I always get a question around this point saying, what if they don't give me all those numbers and they have to? It's not a valid problem unless they give you the values and the probabilities, right? Now in the homework, they're gonna have like one of these empty and you have to figure out what it is. But of course, that's easy. You just gotta make them all add up to 1. So you can always figure out what the last one is. Not a concern. Can somebody tell me, if you look at the handout, it tells you exactly what to make L3. But I can tell, what's in my L1s? What are these?
The value.
What is the X values, X's, and what are these?
Probability.
Probabilities, I love it. So L3 has got to be X times P of X. So that's just L1 times L2. So if I go up to L3, I can tell it L1 times L2. And of course, those are the same numbers that are on the handout. And then just to keep going, I can do this one, L4. I'm going to do it the way I always do it. I always do L1 times L3. That's the way we did it up on the board. It's my X's times my X P of X. And those are the same numbers that are on the handout on Canvas. I like it. And now I need to add up L3 and add up L4. I don't know if anybody remembers how to do this because we did it, but we didn't do it a lot. So I'm going to come out of here, hit second, quit. And now if I go second step, if I go to list right there, if I go to list, I can control my lists. I can do some math on my lists. I can sum up my list. So I can tell it sum up L3. And then what really kicks ass, I don't know if I've mentioned this yet. I almost feel like I must have. But if you hit second enter, it brings back the last thing you did. And why is that kick ass? Because then I can just go back and replace L3 with L4 and not have to go through all the shit. And if you look at the handout on Canvas, those are the numbers that we got at the bottom of those rows, columns, sorry, right? 2.28, 6.14.
Another way is you could just put sum of L1 and L3 in one equation.
Oh, you mean sum of L1 times L3?
Yeah.
Yes, you could. You totally could. And I'm glad you found it out. I kind of let people discover their own shortcuts. So now she has shared that shortcut with everybody. I like it. The problem is, on a quiz, you are going to have to show me all of these anyway. You see what I'm saying? So, okay. And then, here's the last thing I'll show you. And this is the one that always makes people wonder why I make you do all the work. Because you're the humans, and the calculator is a piece of technology we made. Watch, if I hit stat, calc, I have one variable here, right? On the handout, that one variable was the number of email addresses that people have. If you look at that handout later, you can see that's what it was. So I have one variable, but my one variable is not just in L1. L2 is the frequency. It's the relative frequency. So I have to tell it L2 also. So that's X, P of X, L1, L2. And now if I do calculate, these numbers show up on the handout. That's the mean. That's the standard deviation. That's not enough work. That's a great way to check your work. All right. So just to make sure you understand, what we just did is actually 4.1 and 4.2. 4.1 sets up X P of X. 4.2 talks about the mean and the standard deviation. If I'm remembering correctly. So we just have one more section to do in chapter 4. So that is, oh, I'm sorry, Nathan, I missed, was that from recently? Show that again. I'm sorry, dude. Was that something specific, Nathan? Never mind, I'm sorry. I apologize. All right, otherwise I think that's plenty for today. I think we've done quite a bit. Yes, so that is enough. So if you have any other questions, hang out, let me know. Otherwise, you're free to go. Be ready for that quiz on Monday.
So Monday quiz is just on chapter 3, right?
Yeah, the quiz is only on chapter 3, probability.
I had a question about the homework.
Yes.
For when it's saying to like show the symbols, so we just like do we write out the problem, like P parentheses, what should be in the parentheses?
Which problem are you looking at?
24.
24, okay, let me see. Let me see, not too far. All right, here we go, 24. Yeah, okay, perfect. So you just have to write, sort of like we were doing earlier when we did P of B and P of S and all that kind of stuff. Same idea, but here they give you the letters that you need to use.
So you were saying that in the book they use something else but for not, but you're fine with a dash on top of the letter for not?
That's the way that I was taught. So that's sort of the way I just think about it automatically. I've never seen, besides this book, they use a little prime symbol, a dash off the side, and that's just so weird because it's so easy to lose that. So I'm used to putting a bar over. But there is another way to answer that question. So you could do probability of not outfielder, so like an O with a line over. But if you're not an outfielder, what are you?
An infielder.
Yeah. So either PO with the line or PI.
Okay.
Yeah. Oh, somebody's chatting at me. Hell no. Yeah, the probability worksheet thing. Tomorrow we're gonna work on that in groups, and then yeah. So it's not an assignment. It's definitely not an assignment. So don't add that. Focus on the homework. Don't do that. Yeah. Is that all right?
I also had another question about 31. So it says the player is an infielder but is not a great hitter. So could you write that as the probability of an infielder given they're not a great hitter?
Does it say given?
No.
Okay, so don't use given because it's not a given. It says, yeah.
I noticed now. Okay, that was all.
Now look at this one. Of all the outfielders, a player is not a great hitter. That is what I call a hidden given. Given they're an outfielder, the player is not a great hitter. Do you see that?
Yes.
Yeah, so that's hidden given. Yeah.
Okay. Thank you.
I like it. You're welcome.
That was all.
Sure. Yannette, Santiago, Michael, you guys good? Are you guys there? Oh, somebody's there. All right, so if you don't have a question, oh, good. All right. I'm going to leave then. I'll see you guys later. Take care.